Hello and good morning dear students. Welcome back to the online class. Today is Monday, 8th of March 2021 and we are still doing the chapter Exponents. Now let me start with question number 8. Your question number 8 tells us show that this whole is equals to 1. We have to show that this whole expression is equals to 1. Okay. Now we have to show that left hand side is equals to right hand side. So left hand side is this. So I take this as left hand side. Am I clear? So left hand side, please copy what you have. After that, what you can see is the bases are same. The bases are same. So what will I do first? I'll take this b to the numerator. It will be positive. This will be positive c. This will be positive a. Which means this. So x to the power, use the quotient law. Your quotient law, minus becomes plus, isn't it? So x to the power a plus b, x to the power b plus c, x to the power c plus a. Okay? And whatever is the power, it is already there. A minus b is here, b minus c is here, c minus a is here. Okay? Make the power positive and the powers remain same. This and this is this and this. Now what to do? I can use the product law. So this into this, which is this, b plus c, b minus c, c plus a, c minus a. Now, on Friday I've given the formula, right? A square minus b square. So this is the formula of a square minus b square. This is the formula of b square minus c square. And this is the formula of c square minus a square. Okay, so please note it down. This is a square minus b square into b square minus c square into c square minus a square. Now if I use the product law, I can add the powers also. Keeping the same base, add the powers. A square minus b square plus b square minus c square plus c square minus a square. So now I can cancel the powers, because here plus a square and minus a square gets cancelled out. Plus b square minus b square gets cancelled out, plus c square minus c square gets cancelled out. So hence this is x to the power 0, which is equals to, this is x to the power 0, which is equals to 1, and which is our right hand side. So hence we can say left hand side equals to right hand side proved. Therefore LHS is equals to RHS proved. Okay, LHS is equals to RHS proved. So please pause the video and note it down. Alright, let's proceed with the next sum, that is question number 9, evaluate. Okay, question number 9, evaluate is same as simplify. Okay, this is the question given to us. This is the question given to us. Please note down. And now what we'll do is, first I will use the power law out here. 2 into 3n plus 1. So therefore this is same into x to the power 2 into 3n plus 1 divided by this is also same. Okay, what happens now is I can multiply 2 into 3n, that is 6n, 2 into 1, that is 2. Okay, and whole divided by same. This remains same. Here you multiply the powers and this is out here. Okay, now what we can do is, you can see there is x, in between there is multiplication. So hence again we can use the product law. The product law means if the bases are same, if in between there is multiplication sign, I can always add the powers. We can always add the powers. So x to the power 5 plus n plus 6n plus 2, which is this divided by same. This denominator is same. Denominator remains same. Okay. Now here please add 5 plus 2, 7, n plus 6n is 7n. So x to the power 7 plus 7n divided by x to the power 7n minus 2. Alright, now again we are using the quotient law. Take this whole to the numerator, this whole becomes minus, that is x to the power 7 plus 7n minus of this. Okay, please keep it in bracket so that you become clear. Okay, and now when you open the bracket, this becomes minus 7, minus and minus plus, minus and minus plus. Okay, now what happens out here is 7n minus 7n gets cancelled out. X to the power 7 plus 2 is 9. So hence this is our final answer. Okay, so please pause the video, note it down, and then understand it properly also. Okay. Alright, let's move on to the next sum, that is question number 10. In question number 10, we have to evaluate this. Simplify. Everywhere the base is same. A, and A. Okay? The base is same. What we need to do is in the powers. Either use the product law, either use the power law, okay, or the quotient law later on. Clear? First term, keep it as it is. Into. Second term, please multiply. This is in the form of again 2n plus 1, 2n minus 1, which is again in the form of a square minus b square. A plus b, a minus b. Isn't it or not? 2n plus 1, 2n minus 1. So hence the formula will be, this remains same, 2n whole square minus 1 square. Okay? A square minus b square. 2n plus 1, 2n minus 1. Okay? Using the formula. Here you multiply the powers. N into 4n. 4n square. N into 1, m. And here again you multiply in the same way. 2 into 2n. 4n. 2 into 6. 2 into 3, sorry, 6. Okay, now let us see what we get. So therefore, we are getting a to the power 2n plus 1 into a to the power 2n square. 2 to the 4, 4n square minus 1 square is 1 divided by a to the power 4n square minus n into a to the power 4n plus 6. Okay. Now again I'm doing this side. I hope you're clear till here. Now what we'll do? We'll use the product law. We'll use the product law. Add the powers. Add the powers. Okay. So what do we get is a to the power 2n plus 1 plus 4n square minus 1 divided by a to the power 4n square minus n and plus 4n plus 6. Okay, so this is what we get. Let us simplify it further. So this is a to the power, this is 4n squared plus 2n plus 1 and minus 1 gets cancelled out, divided by a to the power 4n squared. This is plus 3n minus n plus 4n is 3n plus 6. Okay, now what we'll do is, now finally we'll take this everything to the numerator. It becomes negative. So a to the power 4n square plus 2n as it is minus of whole of this, that is 4n square plus 3n plus 6. Okay, so now open the bracket with the minus sign. So a to the power 4n square plus 2n minus 4n square minus 3n minus 6. Alright. We're just multiplying minus and plus minus, minus and plus minus, minus and plus minus. Okay, from here to here, from here to here, from here to here. I hope you're getting this. If not, pause the video, understand it. Okay, so 4n square and minus 4n square gets cancelled out. Rest will be same. That is a to the power 2n minus 3n minus n and minus 6. So we'll keep this much as the answer. So please pause the video and note it down line by line. Alright, let us proceed with another question, that is question number 11. In question number 11, we have to prove that left hand side is equals to right hand side. Okay, now please don't get nervous and don't be afraid looking at this type of questions. If you solve this type of questions is very, very, very easy. Okay, but you should give time and then practice it regularly. Not only I'm doing this video, you're doing it in copies and sending me the assignment, that will not work. Okay, you have to sit back after doing the assignments also, make a rough copy and practice it regularly, whatever we are doing every day. Alright, the question is m plus n whole to the power minus 1 into this should be equals to this. So what we'll do, we'll take the left hand side. Take the left hand side, write on LHS. Now in the left hand side, the power is negative. I'm making the power positive by taking down. So this to the power 1. Okay, power is positive. This is 1 by m plus 1 by m. I hope you're clear. This keep it as it is. Okay. Now out here you can take the LCM. What is the LCM? m into n. So m into n is the LCM. Now m into how many times is this product? M into how many times is this product? N times. So n into 1, n plus n into how many times is this product? M times. So m into 1 again, m. Okay. So here I am getting m plus n, and here I am getting n plus m, which is same as m plus n only. M plus n. So 1 divided by m plus n into this is also m plus n divided by this. Okay. If you're not clear, please pause the video again, do check. Okay. So what happens here is this and this gets cancelled out. So I am now left with 1 by mn only, isn't it? This cancel out, so 1 by mn. So this is actually mn to the power 1, isn't it? If the power is nothing, the power is always 1. So hence, if I take back to the numerator, this will be mn to the power minus 1, which is my RHS. So therefore, I can clearly see LHS is equals to RHS proved, isn't it? Okay, so this is how we do this sum. So please pause the video and note it down. Alright then, this much for today. We'll keep this much for today. I'll see you tomorrow in the next one. Take care, bye bye, and practice it well.